Hey everyone. Now that Artemis II has been delayed and we're about something like 18 months away from the target launch date, a lot of this year, 2024, and next year, 2025, is going to be uh, watching the progress of Orion and SLS builds for Artemis II and Artemis III. And so, what I thought I'd do is to run through and provide an overview of some of the hardware elements uh, that will be delivered, what I'm watching for, and other milestones that I'm watching for to get an understanding of the uh, build status for Orion and SLS production. And so let's take a look in this one at Orion. When I talk about the status or watch items for an Orion or SLS build for Artemis 2, 3, or 4, but in particular Artemis 2 and 3, there are several things that I'm looking for. I wanted to run through some of the hardware pieces and some of the milestones that can be general indicators about overall progress or the status of a build. First, let's talk about some of the Orion hardware and milestones that we would expect to see or hear about during production. The Orion Launch Abort System, or LAS, has several pieces that are shipped to Kennedy Space Center for final assembly. Since we're recording this at the beginning of 2024, Artemis II will be the second flight of the crew-rated LAS, which evolved from the units that flew on the EFT-1 launch in 2014 and the Artemis I launch in 2022. The system is centered around three solid rocket motors: the abort motor, the attitude control motor, and the jettison motor. Northrop Grumman is the prime contractor for the first two motors, which fire together to execute an abort. Aerojet Rocketdyne, now a part of L3Harris Technologies, is the prime for the jettison motor, which is used on every Orion launch. For nominal launches, only the jettison motor is used to separate the LAS in the upper atmosphere to improve overall launch vehicle performance to orbit insertion. The crew module and the LAS elements together make up the Launch Abort Vehicle, or LAV, that would separate from the rest of the vehicle in an emergency late in the countdown or early in a launch. In an abort case, which we can see from the Ascent abort test in July 2019, the abort motor and the ACM would fire at abort initiation to quickly get away from the rest of the vehicle, with the abort motor providing 400,000 pounds of thrust and the ACM providing the steering. The abort motor burns out first, and at the end of its burn, the ACM reorients the stack to put the crew module in the right attitude to deploy its landing system parachutes for an ocean splashdown. Finally, the jettison motor separates the LAS from the crew module at the end of the LAS firing sequence. Those three motors are stacked into a tower with the long abort motor at the bottom, the ACM at the top, and the jettison motor in between. The abort motor is shipped with one of the interstage elements. That tower assembly of solid rocket abort motors is attached to the crew module by the motor adapter truss assembly, both structurally and electronically. The MATA has a cone which connects to the LAS tower above, the truss assembly itself, a connector ring lanyard pull for the electrical connections from the crew module to the LAS avionics, and 6 retention and release mechanisms that bolt into the crew module structure. A 4-piece ogive-shaped fairing encapsulates the crew module during atmospheric flight, and additional fillet fairing panels fit over the abort motor casing above the MATA, or in fact over the interstage that is attached to the bottom of the abort motor. The panels are made up of composites, and the MATA cone was redesigned from a composite structure to a metallic one, where the cone is machined from a metal forging. So when looking at the status of the LAS elements, we're looking for when they arrive at Kennedy Space Center. The Launch Abort System facility, formerly the Canister Rotation Facility, is where LAS final assembly occurs, and eventually where the LAS is stacked on the Orion just before the whole spacecraft assembly is stacked onto SLS for launch. In general, the motors arrive at the LASA first from Northrop Grumman and Aerojet Rocketdyne facilities, and are assembled into what's labeled the raceway in this overview diagram. Next, typically, the MATA arrives. The Matacone and truss assembly are assembled and tested by Orion prime contractor Lockheed Martin at the Michoud Assembly Facility in New Orleans. The fairing elements are also assembled and tested by Lockheed Martin at MAF, and those are typically the last launch abort system elements to arrive at KSC. The fillets are attached to the LAS before it is stacked on Orion, but the ogives are not attached until after the LAS and the crew module are connected. Production of the crew module and crew module adapter occurs in what is called the Industrial Operations Zone, or IOZ, which is in the Neil Armstrong Operations and Checkout Building at Kennedy Space Center. At a very high level, assembly and test of those elements starts with the structures. The next phase is welding of fluid tubing to the structure, followed by installation of wiring and systems, components, and equipment, also called integration, and then finally testing and checkout. For the crew module, the pressure vessel is delivered by Lockheed Martin from Michoud to KSC. At MAF, the pressure vessel is first welded and bolted together. After arrival at KSC, the rest of the primary and secondary structure is attached, and then the crew module structure moves into a clean room on the IOZ floor for welding of the different fluid tubes onto the structure. The integration phase, where wire harnesses are laid out and attached, followed by installation of equipment like tanks, thrusters, and avionics, occurs in another area or station of the IOZ. In between, the crew module will go to other stations or cells for proof testing and other tests. The bigger milestones for the crew module are transitions from one phase to the next, and then during integration, there's an initial power-on or IPO milestone. Following that, there are standalone tests, including thermal and acoustic tests, before the crew module is ready to mate to the service module. The crew module adapter is not as complex as the crew module, but it goes through a similar assembly and test flow. The structures include an inner wall, longerons, intermediate frames, and panels that cover the forward, aft, and outboard sides of the donut-shaped CMA. After the inner ring, longerons, and intermediate frames are assembled, then that structural assembly goes into the clean room for the welding phase, and then it comes out for integration and standalone testing before it's ready to mate with the European service module to form the service module. The ESM is built by prime contractor Airbus at its assembly, integration, and test facility in Bremen, Germany. The structure is built by Thales Alenia Space Italia in Turin, Italy, and is then shipped to Bremen for the subsequent phases of assembly and test. The tubing and wiring are installed, followed by the integration phase where systems components are installed, such as tanks for propellant, water, oxygen, nitrogen, and then the thrusters and engines, such as the OMS-E engine, and then the auxiliary and RCS thrusters are installed. Milestones that are sometimes reported are the shipment of the structure from Italy to Germany, installation of systems components, and integrated testing. The major milestone for the ESM is shipment of the completed element from Bremen to Kennedy Space Center. Airbus also integrates Orion solar array wings, which are shipped to KSC for installation on the spacecraft near the end of the production sequence. Typically, those are shipped independently of the ESM itself. Similarly, the OMS engine has the engine itself and then the nozzle extension. And the nozzle is usually tested with the engine in Bremen, and then it is shipped to Kennedy Space Center independently of the full ESM. In addition to the solar array wings, the 3 service module launch fairings, which are called Spacecraft Adapter Jettisoned Panels, or SAJ panels, are produced by Lockheed Martin at Michoud in New Orleans. Those are installed on Orion even later in the production sequence than the solar arrays. The spacecraft adapter cone is also built by Lockheed Martin at MAF, and that is attached to the service module in the final assembly sequence. Here is a list of some of the final assembly sequence milestones. These are not necessarily in critical path order. So some of these milestones, the sequence in which some of these milestones occur will change from build to build. During the integration phase of the crew module build, you'll see the crew module initial power on. We'll see the European service module arrive from Bremen to Kennedy Space Center, and shortly thereafter, the crew module adapter will be mated to the ESM in the lift station in the IOZ. After some additional welding in the clean room between the CMA tubing and ESM tubing, the service module will eventually reach its initial power on milestone. The OMS nozzle will be attached to the rest of the engine at the bottom, and then the spacecraft adapter cone will be installed on the bottom of the ESM. On the crew module side, eventually the heat shield will be installed on the crew module after a lot of the testing and checkout has been completed. And then the crew module and service module will both go through two tests, standalone tests, as they near the point where they're mated together. There's a thermal cycle test, and then there's a direct field acoustic test. And so both of those elements will go through those tests individually before they are mated together. And so then one of the main milestones in an overall build is when the crew module is mated to the service module. And then eventually that kicks off several weeks of integrated testing between the two modules. Eventually, the next major milestone would be a vacuum test, which is something that's still forward work for Artemis II. Once all of the integrated testing of the spacecraft is completed, the solar array wings would be installed on the spacecraft, and then finally the SAG panels would be installed around the service module. Those encapsulate the area from the bottom of the crew module adapter to the bottom of the spacecraft adapter cone. And so those are aerodynamic fairings. They have a similar purpose to the ogive fairings on the launch abort system for the crew module. And once all of those systems have been installed, the spacecraft is basically ready for launch processing. And at that point, the Lockheed Martin build is essentially complete, and Lockheed Martin would hand the spacecraft over to Exploration Ground Systems for launch processing. Thanks for watching, and in the next one, I'll go over some of the watch items, hardware elements, and milestones that I'll be looking at for SLS builds.